Hello guys, welcome back to another fun and exciting week of lectures. This week we're gonna talk about variables and how we use them and how we deal with them. So objectives. Okay, so what are variables? Well, the technical definition is that these are basically memory locations inside the computer which are used to store data while an application or program is running. So we all know that basically by computer memory locations we mean that computer stores ones and zeros and stuff like that, and this is basically what they work with. For us, variables mean stuff where we store meaningful information which we work with. So, and while designing our program or applications, we might be dealing with a lot of variables. So it's very important to have meaningful names for the variables so that we know what it is like in the future when we have too many variables, and if they don't have meaningful names, then we might have a problem about what was its purpose. Besides that, we generally use some sort of standards to name those variables. Generally, camel casing is used. There are several rules which we'll get into. But before that, each variable must be assigned a data type. So what is a data type? Well, as an example, like an integer is a data type, right? So 0, 1, 2, 3 to whatever, and even negative 1, 2, 3. Any whole number is an integer and it's a data type. A data type which has only characters like A, B, C or stuff like that is called a string. And it's basically a bunch of characters, a sentence or paragraph, whatever you want to have. That can also be a variable data type. Even an object is actually a very big data type. So the objects we were working with till now were variable data types. They are basically a class of data or a class of variable. Also, like Unicode is one of those coding schemes for characters like text, like sentences or stuff like that, which basically when the computer stores it, these texts go back to numbers, which are basically representing the symbol for the text. So like capital A might be assigned like a decimal number of 45 or something, and that's what the computer stores in the memory location. But when we actually see the see the information, we always see the text if it's a string character. So Unicode is basically a unique numerical value assigned to each character. Okay, so now that we have that out of our way, so what are the rules in naming a variable? Well, the variable can only begin with either a letter or an underscore. So no numbers, no spaces or stuff like that. It can only contain letters, numbers, and the underscore character. So again, no special characters like suppose exclamation mark or quotation or anything like that. And also there should not be any spaces in a variable name. You might want, I don't know why, but if anybody wants thousands of characters in a variable, that still can be done, but generally the recommended maximum is 32, not more than that. I don't know why anybody would want more characters than that, but you still can do it. Also, it's a good idea not to use common or reserved words which like the programming language uses. So like Visual Basic uses these words such as sub or private or class or close, if, else, etc., which are generally used for coding or programming commands. So It's a very good idea not to use those things, even if they let it you, which they probably won't. So you have to have some sort of pattern in your variable, which are like not commonly used as programming or stuff like that. Some examples are given here. Some examples of wrong or invalid names are also given here. So you can see that you cannot begin with the number 2014 is not how you begin. No spaces, no dots, no dollar signs. Like even the last one, R2Q, it's actually like it's valid, but it doesn't make any sense, right? um, so back to data type. As you can see from this table here, there's plenty of data types. I'm gonna go over some of the useful ones or the important ones. So Boolean is basically a data type having only like two states, 1 or 0 or true or false or on or off. So it's basically what we know as a bit. So I guess space where you can only put in zeros or ones. However, you see that the memory required for a Boolean is actually 2 bytes, which is 1 byte is basically 8 bits, or 2 bytes is equals to 16 bits. So the reason why this is basically that the minimum memory location each data type has to have is 2 bytes. So you can't go smaller than that for a memory location. So I mean, that's the reason for this weird memory assignment. Besides that, char or char, not car, car, I don't know, some people also say char, but char is generally the standard way of saying it. It's basically a Unicode character, and it's only used for text or strings. Also has 2 bytes. Dates use 8 bytes. Decimals and doubles are basically floating point numbers, meaning that you can have like a fraction or even a whole number with decimal places, like something like 7.928 whatever. And as you can see, the double needs smaller memory locations, 8 bytes, and the decimal needs the double that memory location. But with that range also comes um, uh, with that memory location increase also comes a increase in range of the big or the smallest number you can store. Other than that, like there's integers which can only store whole numbers, and it can be long or short. So the short one having only 2 bytes only can have a range between minus 32,768 to 32,767. On the other hand, if you have 8 bytes, and then you can use the long integer, which has a huge range, as you can see, something in the order of, I don't know, 10 to the power 15, 16. Integers, normal integers, which only take 4 bytes, have a little or considerably smaller range than the long, but much larger than the short. And all those ranges are why these memory locations are different. Objects is a data type having 4 bytes. String is basically text, and the number of bytes vary according to the number of characters. So that's about all the data types there.